go on, I will be making references to places you can look in your Math Interactive notebook or possibly other videos that you can watch to help you better understand how to do some of these things. So the first thing it asks us to do is convert fractions into decimals. So we need to write each fraction or mixed number as a decimal, put a rectangle around answers. So to convert a fraction or mixed number as a decimal, I need to do the top divided by the bottom. In mathematical terms, that is the numerator divided by the denominator. In this particular problem, my numerator is 2 and my denominator is 5. So if I was to do long division, I would put 2 inside the house and 5 outside the house. How many times can 5 go into 2? 0 times. How many times can 5 go into 20? 4 times. 4 times 5 is 20. 20 minus 20 is 0. So, to convert 2 over 5 into a fraction, the answer is 0.4. Another way to do this is in my calculator, I would put in 2 divided by 5. So I'm going to pull up my calculator. Two divided by 5, it equals 0.4. So my answer is correct. Number 2. And you only need to do it one way. You're either going to use a calculator and do it this way, or you're going to do it long division. Not both. Either or. Alright. Number 2. 4 over 33. You already know if I was putting that in my calculator, I will put in 4 divided by 33 and hit equal. I keep getting 0.121212121212121212, and it just keeps on going. Alright? I don't want to write all these numbers. I'm not supposed to write all these numbers. Mathematicians have a way to write this answer. So, 4 divided by 33 equals 0.12. And the number I keep seeing is 1, 2. That's the pattern. So I put a line over it. If I was doing this with long division, 4 goes inside the house. 33 goes outside the house. How many times can 33 go into 4? 0 times. How many times can 33 go into 40? It could go in there 1 time. 1 times 33 is 33. 40 minus 33 is 7. I bring another 0 down. How many times can 33 go into 70? 2 times. 2 times 33 is 66. 70 minus 66 is 4. Bring down another 0. How many times can 33 go into 40? 1 time. 1 times 33 is 33. 40 minus 33 is 7. As you see, the process would keep repeating over and over and over. So I would take this and I would write 0.12 repeating. Alright. And I will put a square around my answer. Okie dokie. Let's keep going. Number 3. Number 3 says negative 2 and 8/45. So I have this negative 2 there. Well, my negative 2 is a whole number. Nothing's going to go away. So I just need to remember that this negative 2 should be in front of my decimal, and whatever I get For 8 divided by 45 will be after my decimal. So we'll bring up my calculator. 8 divided by 45. I get 0.17777. Uh-oh. And then at the end it's an 8. Well, this would have been a 7. If I had more room, it would continue to be 7s, but our calculator is programmed to round this last number. So do not pay attention to that. That is a rounded answer. But the number that I see repeating is the 7. So I write, I do not put the 0, because this is 0.17 repeating. This negative 2 right here is going to take the place of the 0. So negative 2.17 repeating is my answer. All right? And as you know, you can do this with long division. Number 4, again, I have a whole number. So I know my answer is going to have a positive 4 in there, and I can put the decimal. Then I know I need to do 1 divided by 8. 1 divided by 8, pull up my calculator. 1 divided by 8 is 0.125. I know I had supposed to have a 4 in my in front of my decimal, not a 0. So everything after the decimal, I write. And there's my answer. All right. For number 5, 6, 7, and 8, they want us to convert decimals into fractions. So we're going in the opposite direction. Convert decimals into fractions. So these are the 2 ways that you can do that. First, if you're familiar with place value, the number right after the decimal is the tenths, and then it's the hundredths, and then thousandths, 10,000ths, hundred thousandths, and so on and so forth. All right? So if I look at this one, there are 2 digits. This last digit is in the hundredths place. So I would write the number that I see, 48. Do not put the decimal. Do not put the decimal. 48 over 100. And then you would reduce from there. Right? If you are not very strong with remembering your place values, there is a shortcut that you can do, or another way that you could remember. If I take the number that's behind the decimal, so 48 goes in the numerator, then I count the number of digits behind the decimal, 1, 2. So since there's 2 digits behind the decimal, I need 2 zeros, and then I put a 1. All right? So it's 48 over 100. From there, I reduce. I'm going to reduce by 2, because they're both even. 48 divided by 2 is 24. 100 divided by 2 is 50. They're both still even, so I'm going to reduce by 2 again. This one is 12. This one is 25. This is my final answer, 12 over 25. All right. Mrs. Robinson is doing what she always does. this. If I look here, I see a negative 3. So that tells me when I create my fraction, my answer should have negative 3 as a whole number. All right? Now it's time for me to deal with 16 repeating. Okay? Point 16 repeating. You might say, oh, it's 2 places, so I need 2 zeros. Put a 1, that's 100. That's not true because it's repeating. You might say the 6 is in the hundreds place, so I'm going to put 16 over 100. That is not true because this is repeating. This is repeating. All right? So that means it goes on forever. It goes way past this. So we have a different process that we need to do. I'm going to show you the long way first, and then I'll show you the short way. So we need to let x equal whatever is behind the decimal. So 0.16 repeating. And then we have x equals 0.16 repeating. Since the number that's repeating goes to the hundreds place, I'm going to multiply each side by 100. I forgot to put the repeating sign over there. X times 100 is 100x. 0.16 repeating times 100 is 16.16 repeating. From there, I'm going to enter this equation. So x, I'm going to subtract x, and I'm going to subtract 0.16 repeating from this side. I want to just erase that. It wasn't over far enough for me. All right? And I want to subtract 0.16 repeating from this side. 100x minus x is 99x. And 16.16 repeating minus 0.16 repeating is simply 16. 90, I want to get x by itself, so I divide both sides by 99. X equals 16 over 99. So this is the other part of your answer. So your answer should be negative 3 and 16 over 99. All right, Mrs. Robinson, what is the shortcut? If that was the long way, what's the shortcut? Here's the shortcut. There is a rule that I'm sure was discovered a long time ago, but I like to use this rule. Well, anytime I see a repeating decimal, I immediately go, if both numbers are repeating, this has to have 9s in the denominator. Let me say that again. If I see a repeating decimal and both digits are under the repeating symbol, or all the digits are under the repeating symbol, the denominator has to have 9s. Repeating 9s in bottom. So if it's repeating, the 9s are in the bottom. So let's look at this. This is repeating. So I write 16. 2 digits are repeating. So I need a 9 for each digit that's repeating. I then bring in my negative 3. That's the shortcut. If it's repeating, 9s go in the bottom. So instead of zeros, you're putting 9s, and you don't put the 1. Okay? So 16 over 99. Negative 3, 16 over 99. All right? Number 7. If I use this rule right here, repeating, yes. So 9s go in the bottom. 0.3 repeating, so I need a 3 in the numerator. 1 digit is repeating, so that's 3 9ths. All right, and from there I reduce, divide by 3, 1/3. All right, remember you could also do the equation where you let x equal 0.3 repeating, and we could solve it algebraically. All right. Number 8, 5.075. So So I know that I need a whole number of 5, and then I have .075. The 5 is in the thousandths place. So I put 75, because I don't need that 0, over 1,000. From there, I would reduce. I also could do, there's 3 digits behind the decimal, so I need 3 zeros, and put a 1, and the 75 goes in the top. I am going to reduce this by 25. Remember that 5 has to go in the front. 75 divided by 25 is 3. 1,000 divided by 25 is 40. This is my final answer. If you are unsure, you can always take your calculator and check your work. 12 divided by 25.48. That one's right. 16. Oops, wrong button. 16 divided by 99. I don't know why I hit plus. 16 divided by 99. 0.1616, that's repeating. And I have the -3 that I kept. 0.3, I said it's the same as 1/3. 1 divided by 3. 0.3 repeating. And this last one, 0.75, I said it's the same as 3 divided by 40. 0.75. So that's the way to check my work after I've done it. All right, this next section, rounding. Rounding. We actually put this on the test because there were concerns with students being able to round and understanding rounding and utilizing rounding. So this is a time where you're going to need to know your place values. It says round each decimal to the nearest whole number. Whole number, all right? So it didn't say the nearest ones, it didn't say the nearest, it just said the nearest whole number. And we know, we learned that whole numbers are anything from 0 and up, okay? Whole numbers, anything from 0 and up. So 0 to infinity, all right? Whole numbers, no decimals. That's what whole number. So let's look at number 9. The nearest whole number. So I'm looking at the 1, the first one, because that's my nearest whole number. I have 11.51. The number after the 1 is a 5, and the rule is 5 or more, go up. 4 or less, stay. Okay? 5 or more, you can't see my go up. 5 or more, go up. 4 or less, you stay. So since this is 5, my 11 becomes 12. Well, my 1 becomes a 2, and so it becomes 12. Next one, 89.77. I am going to look at the number, my first whole number. So 89.77, the rule says 5 or more, go up. 4 or less, stay. Well, the number after that 9 is a 7, so that tells me I need to go up. Well, 9 goes up to 10, okay? And if I have 10 ones, that really means this should go up to 90. All right? Because 9 went up to 10, and you got to carry the 1. So this went up to 90. Next, nearest whole number. My whole number would be in the front, so that is a 0 that's really there. Okay? So 0.434, the number 5 or more, go up. 4 or less, you stay. So 4 or less, so 11 should be 0. Number 12. Looking at the 1, remember, 5 or more, you go up. 4 or less, you stay. So this is a 4, so this is 1. All right? Now, the next part says round each decimal to the place value indicated. So I have to pay attention. All right, I got to pay attention. This one says tenths. This one says hundredths. This one says thousandths. And this one says ones. So they're all different. They're all different. So let's see what we get. So this one says tenths. This is my tenths place, where the 9 is. So everything in front is going to stay, and I'm trying to decide, is the 9 going to become 10 or stay a 9? I look at the number after it. There's a 3. And 3 is 4 or less, so it stays a 9. So 12.9. That's the nearest tenth. 14. They want the nearest hundredth. All right, so tenths, hundred. So I'm at the 2. All right, everything in front is going to stay. So I know I'm going to have 0.6, and I'm trying to decide if I'm going to keep that 2 or go up to a 3. The number that you need to look at is the 3 behind the 2. And since that's 4 or less, it stays. So 0.62. All right, 15, the nearest ones. So I'm looking at this 9, and I'm looking at the number behind it to decide, do I keep it a 9 or does it go up to 10? All right, so if it's 5 or more, the number changes. If it's 4 or less, it stays the same. So since this is 5 or more, the 9 becomes a 10. All right, 16, to the nearest thousandths. So tenths, hundredths, thousandths. I'm going to the second 2. All right, and then the number that I'm going to be looking at is behind it. It's a 6. So everything in front of that 2, I'm going to be keeping. 3.72. Now, is this 2 going to stay a 2 or go to a 3? Well, since a 6 is after it, it becomes a 3. First page is done, people. Great job. Let's go to the next page. Powers and substitution. All right? So, powers and substitutions, what you have to do is write each expression using exponents. Exponents, we know all about exponents. We know that the large number is the base, and the small number is the exponent. The exponent is up high and the base is down low. That's what Miss Egan says, all right? And I say the base is the big number, the exponent is the little number. So we have lots of big numbers here, regular size numbers, and it's repeated multiplication, so I need to count how many times I have to multiply the same number, and then I'm going to use my exponent to represent how many times I have to do that. So if I look at the first problem, I have 1, 2, 3, 4 3s. So I'm going to write the base of 3, and I needed 4 of them. Then I have 1, 2, 3, 4 n's. So I'm going to write a base of n and then an exponent of 4. Number 17 is done. 18. The base that I see is negative 5/8, negative 5/8, can also, I prefer you to write it like this, but if you write it like this, negative 5 over 8, and each one of them gets a little 3, that's correct as well. That's done. Evaluate each expression. We're here. Evaluate. This is that substitution. All right. Number 19, g squared minus h cubed. Given g is negative 4 and h is 2. So we're going to rewrite this problem with the given values. So I see a g, but no, I don't need to write that g because g is negative 4. So I'm going to write negative 4. I'm going to put it in parentheses. All right. And then there's a power of 2 right outside. Then there's a minus. And then h. Wait, they gave me a value for h. H is 2. Then it has an exponent of 3 on the outside. Now, using order of operations, I can begin to solve my problem. So, negative 4 squared, I'm going over here, negative 4 squared, which is negative 4 times negative 4, negative, here you go, negative 4 times negative 4. Positive 16. Don't believe me? I just put it in the calculator for you. All right? So, 16 minus 2 to the third power. All right? That's the same 2 to the third power. That's going to be 8. Now I need an answer for this. 16 minus 8 is 8. That's my final answer for there. 19 is done. Now we're going to look at number 20. It says the quantity of, whenever you see these parentheses, you start with the quantity of a plus b cubed, close parentheses, plus a. People always miss this plus a. Given a equals 10 and b equals negative 1. And that's why it's very important that you take your time as you're writing this out. So, parentheses, a. Instead of a, I'm going to put 10 plus b. Instead of b, I'm going to put negative 1. I'm sorry, I didn't put that in parentheses. Okay, so I got parentheses, 10, so I put the 10 in parentheses, plus b. B is negative 1, so I'll put that negative 1 in parentheses, q. Every time you add a number to it, just put it in parentheses so that the whole quantity stays there. And then close parentheses, plus a. Whew, lots of parentheses, all right? Switching colors. So I got to do this, what's in here first, all right? And I have an exponent in there. So negative 1 to the third power, all right? So parenthesis 1, close parenthesis, to the third power. It's negative 1. Alright, so negative 1, my plus, and then I got a 10 here. Alright? Hopefully you guys can still see. And then I bring down my plus, and then I got a 10 here. So now, I have 10 plus negative 1. What's 10 plus negative 1? That should be 9. And then I got a plus 10 out here. So 9 plus 10 is 19. All right? You may have to watch that one a few times. Like I said, people always forget the plus A. I know it looks a little confusing, but please remember, whenever you add a quantity into a problem, just put it in parentheses, just in case. Because right now, yes, they're whole numbers, they're constant numbers, but sometimes you actually plug in a different term, a whole nother term into here. So just put it in parentheses for best practice. All right? Laws of exponents. Laws of exponents. I'm just going to go through here. If I remember my laws, I know that when we're multiplying, we're going to add the exponents. And we're multiplying, so I'm going to add those exponents. And I'm multiplying, so I'm going to add those exponents. And I'm dividing, so I'm going to subtract those. divided, so subtract those. I'm dividing, so I'm going to subtract those. Right here, I have parentheses and an exponent on the outside, so I'm multiplying. Parentheses with an exponent on the outside, I'm multiplying. Parentheses with an exponent on the outside, I'm multiplying. Okay? So I have some basis of what I'm doing with the exponent. With the exponent. Now, if I look at my directions, it tells me no negative exponents are allowed in my final answer. Okay? Negative exponents are the ones you have to flip over the bar. Okay? So let's begin by looking at these. Multiplication. So, I always do my exponents first. Since I have the same base, I can add the exponents. So a, 4 plus 5, equals a to the 9th. That's the final answer there. 22. I have 3 to the power of 1, x to the power of 6, 4 to the power of 1, x to the second power. Well, since 3 and 4 are constant numbers, they're already simplified. I can do 3 times 4. 3 times 4 is 12. All right? Then I have x to 6, x squared, since they have the same base. Since they have the same base, I can just add those exponents together. So x, 6 plus 2, my answer is 12x to the 8th. Remember, we're adding. We added these. All right? That's my final answer. 23. I have 2 n to the 3rd, p to the 3rd, 5 m to the 5th, n to the 4th, p to the 4th. So let's start with my constant values. I have a 2 here. I have a 5 here. Their exponent is 1, so I can go ahead and multiply those like normal. 2 times 5 is 10. That's done. Let's look for some common bases now. A common base. Over here I have n to the 3rd, and I have an n to the 4th. And my rules tell me to add. So 3 plus 4 and 3 plus 4. Let's look for some more. I have a p to the 3rd and a p to the 4th. Okay? So my rules still tell me to add. So p 3 plus 4. And then I had 1 left. So I'm done over here, but now I'm over here. I have this m to the 5th. So I just bring it straight down. M to the 5th. All right? Am I done? No, you are not done. You need to do the addition. All right? So my final answer is 10 n to the 7th, p to the 7th, m to the 5th. Final answer. Number 24. The exponent rule says if I have the same base, I can subtract the exponents. So I have b 4 minus, whenever you don't see a number, that's a 1. Sorry for the loud noise. So b, whenever y'all see a number, that's a 1. 4 minus 1 equals b to the 3rd power. All right? 25, once again, I have 12, a to the 6th divided by 4, a to the 3rd. I have these constant numbers, these numbers that don't have an exponent, they're already simplified. So I got 12 divided by 4. I can handle that. I know how to deal with division. 12 divided by 4 is 3. So I got 3. Now I have a common base that I can put together. I have a to the 6th divided by a to the 3rd. My rule tells me I can subtract. So a, 6, the number on top, minus the number on the bottom. This would be 3a to the 3rd power. number 26. Same thing, I'm looking for any constant values I can get rid of. I have a 4 and a 12. Don't rush, don't get cocky, because this is 12 divided by 4. This is 4 divided by 12. Tells me I'm going to have a decimal. Okay? We don't want decimals. We just want you to reduce it down as low as possible. So 4 over 12, I can divide both of those by 4. 4 divided by 4 is 1. And 12 divided by 4 is 3. So I have 1/3. Then I have m to the 15, m to the 9. We're still dividing. So I have m 15, number on top, minus 9. Okay, and I can put it just next to it because I consider it like a whole number. And then I have p, common base of p. P to the 20th, p to the 11th. So p 20 minus 11. All right? Then I go with my final answer. You can write this as 1/3. I'm going to shrink this a little. Move it up. There we go. So, you can write your answer as 1/3. 15 minus 9 is 6. M to the 6, and 20 minus 11 is 9. So you can write it like that, or you can just put m to the 6th, p to the 9th on the top, and with 3 in the denominator. All right, we're doing good, people. We're doing good. 27 tells me I need to multiply. I only have one base in there, and that's a d, and this to the exponent of 5, the number on the outside is a 3. I mean, the exponent on the outside is a 3, so d, 5 times 3 is 15. This one tells me I also have to multiply. Here you can do the rainbow. Okay, I have two bases, so that exponent of 6 needs to travel twice. So I have a base of negative c 3 times 6, and then I have a base of f 4 times 6. So my final answer is negative c 3 times 6 is 18, and f 4 times 6 is 24. This is 24. All right. Next, I have parentheses. This tells me I need to multiply, so I'm going to rainbow again. I needed some room so I can rainbow. I have a base of b, a base of a, and a base of 3. All right. You can't see my exponent anymore. A base of b, a base of a, and a base of 3. There we go. That's better. So my first base is 3, and that's a 1, so 1 times 7. My next base is a, that's a 2, so 2 times 7. And my final base is b, it's raised to the 4th, so 4 times 7. So my final answer is 3 to the 7th, a to the 14th, b to the 28th, and since I have a constant number raised to a power, I open up my calculator. 3 raised to the 7th power equals 2,187. So I would simplify this as 2,187, a to the 14th, b to the 28th. All right. 30. I'm multiplying, so this tells me to add the exponents. That's the first thing I'm going to do. So I have the base of 2, and I have negative 3 plus a negative 2 equals negative 3 plus negative 2 is 2 to the negative 5. My rule tells me at the top, if I go back up, right here, no negative exponents. So my rule is flip it over the bar. So let's do that. Let's do that. Let's flip it over the bar. So right now my bar is right here because this is a whole number. And to turn any whole number into a fraction, you just put it over 1. So I need to flip it over the bar. They need to flip spots. When they flip spots, my exponent is become positive. So I now have 1 over 2 fifths. All right? So that's number 30. $31. All right, I got a to the 0 power times negative 3 times, I'm sorry, a to the 0 power times a to the negative third power times a to the 6th. All right? If I know anything about my exponent laws, I know anything to the 0 power is 1. So I know that's just going to be 1. And then right here, I'm multiplying, so I add those exponents. So 1 times a to the negative 3 plus 6. So 1 times anything is that number, so I have a to the third power. So if you're not strong in your integers, I have 3 negatives, 6 positives, so that means they cancel out. The negatives and positives cancel out, and it'll leave me with 3 positives. Okay, 32. I have x to the negative 6, y to the negative third, divided by x to the negative fourth. I see on the top, I can't combine anything. On the bottom, there's nothing to combine, so I got division. This tells me I'm going to subtract my like bases. All right? So my like bases in this particular problem is x to the 6th and x to the 4th. So I'm going to go x negative 6 minus a negative 4. And then y is all by itself, so y to the negative third. Well, right here I can do double dash, so it's negative 6 plus 4. So it's going to be x negative to the negative second power, y to the negative third. Well, if we look at our rules, it tells me I need to flip it. Right now, there's a 1 down here, and I need to flip it. I need to flip that way. And each one of these that has a negative, I need to flip down. So x to the negative 2, that has to go down. And y to the negative third has to go down. So 1 over x squared y cubed. If one of these was positive and one was negative, you would keep the one that's positive at the top and bring the other one to the bottom. Okay? Remember, if you have questions or concerns, come see us, leave a comment, ask questions. We're almost done. Applying laws of exponents. Finding the missing exponent. So, I know that this is a multiplication problem, so my rule tells me that I would add. Alright? But I don't know what this is. What's the opposite of addition? Subtraction. Alright? So, instead, to figure out what this exponent is, I'm going to subtract. So I'm going to go 5 minus 7. Alright? 5 minus 7. 5 minus 7 is negative 2. So that is my answer. That's my missing exponent. Alright? Here, this is division. So I know that to get this answer, we had to subtract. The opposite of subtract is addition. Alright? The catch, though, is you only would add if you knew this bottom number, but since you don't know the bottom number, it's like these are going to switch places. Switch places. Alright? So you're really going to have b to the negative 1 over b to the 10th equals what? Alright? So negative 1 minus 10 equals negative 11. Okay? So if the denominator is one that's missing, you're still going to subtract. But if the numerator is missing, if that's the one that's missing, then you're going to add the exponents. You're going to have to do the opposite. All right, you're almost done. Thanks for sticking in there with me. Zion wanted to measure how much popcorn could fit into a square box. I'm drawing a picture. Square box. He wants to know how much popcorn would fit in a square box. What would the volume be of a box with sides equal to 3x to the second power? Well, first thing, volume. I know volume is cubed. Volume is cubed. All right? Because volume has three sides, and I'm looking for my word box. That's why I zoned out. And we know box, the volume of a box is side times side times side, which is the same as a side cube. All right? So since we know one side is right here. We know one side. All I got to do is cube it. All I have to do is cube it. So 3x to the second power. I got to cube this side. Cubed. All right? So whatever I have, that's why when we're plugging in stuff, see, I'm plugging this equals s. When I'm plugging stuff in, I put it in parentheses because sometimes it's more than just one digit. So now what do I do? Well, remember the rainbow? It needs to go to each base. So I got 3, 1 times 3, and then I got x, 2 times 3. 3, 1 times 3 is going to be 3 to the third power, and x, 2 times 3 is going to be x to the 6th. I can find out what 3 to the third power is. 3 to the third power is 27x, and I keep my x to the 6th. So 3 to the third power is 27, and I keep my x to the 6th. All right? Did I have to draw a picture? No, but for some people, they may need to see the picture and realize, oh, we're dealing with volume. But anytime you're dealing with volume, you're dealing with cubed. If you were dealing with area, it would be squared. Okay? So volume is cubed, area is squared, and we only can really do this if we're dealing with a square, because if you're dealing with a rectangle or a different shape, you won't have you won't have the exponent this way. It will be set up a little different. All right? So I hope this helps, and thanks for watching. Posting it as soon as possible. Have a great night.